Hi all. My name is Yeswanth. I'm from Automation and Robotics Department, M.Tech. My roll number is 11. So our project is another like my teammate Harshni from Machine Learning. Harshni, introduce yourself.
Myself, Harshni, I'm from AIML, M.Tech.
Our project is cardiovascular heart disease, a machine learning comparison project. Introduction to the project. Cardiovascular heart disease encompasses a range of conditions affecting the heart and blood vessels, including stroke, failure, and many things. So our project CHT is characterized by normal and blockage of blood vessels, leading to reduced blood flow and oxygen supply to the heart, resulting in various complications. So, our goal of the project is to predict whether an individual suffers from cardiovascular heart disease using some predicted and to find major risk factors for a cardiovascular heart disease. So, we use a machine learning algorithms for some algorithms to predict the disease. To optimize and diagnose the condition of a heart of a human being. So uh, we kept in 3 points. Early detection and diagnosis. So early detection may help people to diagnose themselves and uh, uh, get improvements and take necessity care for their heart. We did improved outcomes and prevention and management. So early diagnose people lifestyle modification and medication to manage risk factors and slow disease progression and reduce healthcare cost. So most of them can't afford to do diagnosis of their own body. So for them, we made this project to be a lower cost level. So our objective of the project is to develop predictive models for CHT. Second point is future engineering and selection. So we select some part and like the selection need to be very accurate and compare model performance. So each model will be compared for accuracy of the performance. So address data imbalance. So we need data to be balanced and need to address the data for more accuracy. So enhance interpretability and incorporate time-dependent risk factors. So how much the time and the risk factors of a human being can be estimated in this diagnosis. So ensure the generability and deploy user-friendly system. So the UI need to be user-friendly system to understand the user, and the user can easily walk into our application and he can easily identify the key points of our application and identify like it. We need to have ethics and bias issues. Like we can also identify and mitigate that. So facilitate real world application. So this can be a real world application in most cases. So here, as I said before, we are using some machine learning algorithms to make this diagnosis very accurate. So here we are using 6 algorithms of machine learning. One is logistic regression and linear discriminant analysis. Third one is decision tree and boost support vector machine and random forest. So logic regression is uh, mainly to identify the significant risk factor of and predict CHT presence. And LDA is mean linear discriminant analysis. So this thing we use it for reduction technique for classification patient without CHT. So and next decision tree. It is for complex relationship between risk factors and CHT. It is a rule-based system or rule-based model, and XG boost. So this thing will be uh, helping in performance of powerful gradient and boosting algorithm in identifying non-linear patterns for CHT prediction. So this can be a powerful boosting algorithm and support vector mission algorithm. So this algorithm is having ability of kernel based learning algorithm. So this can create decision boundary so that effectively separates the patient with patient with CHT or without CHT. So this thing can be uh, done support like this can be separated from like without CHT. The patient can diagnose easily. And last one, random forest. So this thing is accuracy. They like the analyze the accuracy of decision tree of a robust prediction of CHT. So we build a model by using this six algorithms of machine learning. So the model will be more accurate by using these six algorithms combined. Again, next slide. So the challenges we are facing is handling time dependency of data and computation and resource containts and generalization across population and future selection and engineering the product. So handling time dependent and data is like CHD progressive is often influenced by time dependent factor. So example, changes in lifestyle or treatment over time. Uh, Static models may not capture this dynamic effect. So next thing, computational and resource contents. So depending on the size of a data set, the complexity of the model, computational power, and memory requirements may be high. So especially for deep learning models. And next, generalization across population. So the CHD risk factor vary across demographic groups, meaning a model trained on one population. Example, a particular age group, ethnic group, or region may not generalize well to other. And feature selection and engineering. This thing is identifying relevant features that have predict power for CHT is crucial. So data set and processing techniques. So the techniques we are using is divided into three parts. So first we need to collect data and we need to clean the data. So like we need to remove the like non-necessary data, and so that we need the clean data for training and future engineering. So transform to exchange predictive of power of the model by this process. So here we are talking about evaluation matters. So here confusion matter, like some are true classes and some are predicted classes. In that like we will be predicting like some are false positive and some are true positive, and uh, like the accuracy is depending and precision and recall and FN score. So this can be done in the code. So models, logistic and regression model for heart disease prediction, and model description and model evaluation and model optimization. So first we will be doing model description. So what the model does and everything will be described in the like according to that we will be developing the model description, and we'll be evaluating the model, and next we'll be optimizing the model for better prediction and evaluation and optimization. So, next slide. So this is logistic regression model for heart disease prediction. So this is the algorithm for heart disease prediction. So this can be explained in the code. So these are the screenshots of code. So later this PPT will be explaining the code which we did in Jupyter. Okay, so this is very near discriminant analysis for heart disease prediction, and here is the detailed flowchart of how this thing, like this, the algorithm will work. Uh, Decision tree classifier for heart disease prediction is, as I said before, we need to do a model description and model evaluation and model interpolation. So this thing will be having the task driven risk, and like it will be predicting the risk of the patient and like risk deposit and risk beyond, and so this all will be including in this process. So this is the decision tree for heart disease prediction. So it is a tree structured algorithm. So this is a screenshot of the code and the algorithm, and the right side part is the output of this algorithm. So here are the next. So like we'll be taking some patients, and we'll be giving to this decision tree algorithm, and that will be predicting the true positive and true negative side of the values. And this can be giving accuracy, and the confusion matrix also given by this. And this is tuned decision tree for heart disease prediction. So this, after a decision tree, the whatever the data is getting, that will be tuned decision tree for heart, and left side is the algorithm and right side is the output of that. And same, and this is the outputs. So gradient boosting classifier for heart disease prediction. So gradient boosting, it will be boosting the algorithm to clean, and so the depth of the data and the accuracy score it will be taking, and confusion matrix. So XY is XY values, like training data, like X values for positive, Y values for negative, like that. The right side is the output. So accuracy is 0.5, sensitivity is 7.0. So random forest, as I said before, model description and model evaluation, model uh, robustness. So this is the output of random forest for so that this is the classifier. So the bottom is max leaf nodes, and the y-axis is the score. So at 0 point it is in 50. So it is very accuracy because it is in red color. So right side you can see the accuracy is red colors. So it is basically the number of leaf nodes is the most impactful parameter of this quality of the fit. The comparison between between a subset of values shows a maximum at 30 feet leaf node. So for the test set accuracy. So this is that. So these are the screenshots of the code. So in the code we can explain this thing. So this is the code. So this is support vector classifier. This is a comparison, and for performance evaluation comparison analysis, like we did machine learning models. So we divided like model A and precision model E. So this is having 90% accuracy and 85% precision and 80% recall. So it will recall, and it will again given to decision tree model demonstrate good recall effectively, identifying all positive cases. So clinically implications and future directions. So early detection, we can help people who are having really hard, who are having heart disease. They can intimate it early, so they can take precautions necessary for their heart. So this can be early, but early detection. So risk stratification. So machine learning can assist in identifying individuals at high risk for and the targeted preventative measures can be taken. So this will be helpful for high risk uh, individuals and personalized medicine. So machine learning model can contribute to personalized medicines, direct to treatment plans and based on individual risk factor and health data. So conclusion of our project is high predictive accuracy and with random forest, early detection and risk stratification, personalized treatment approach, impact on healthcare costs and efficiency for all people, clinical and research implications. So we can still we can go beyond and we can train the data along every day. Multiple users will be using and collected data, and will be training multiple times. So a path towards data-driven healthcare. So the more they use this thing, and the more data is collected. So this is basically a data-driven healthcare system. So from here on, Harshni will from here on Harshni will take she will explain the code. So enter the algorithms and everything. Harshni, you can continue here.
Yeah. So here we are importing the libraries like pandas, NumPy, and Panda is used for handling and manipulating the tabular data such as CSV files and data frames. And NumPy we use for numerical operations such as arrays and for mathematical computations, as we all know that. And we are using here matplotlib for plotting the histograms and scatter plots, and hence customizing the specific line plots. Mm, Next, we are using the pre-processing of the data, that is sklearn pre-processing, that we are importing standard scalar and min-max scalars. So standard scalar gives the scale data which has the zero mean and the unit variance values, and min-max scalars have the range of 0 and 1 same values according to the tree-based models. And then we are going to the statistical models, which is like import stats model.api, that we have specified as SM in the code. And then we are going through the machine learning models such as linear models and decision tree, and ensembling models and discriminant analysis and support vector machine and k-nearest sniper algorithm according to the feature selection thing. Then model evaluation. We are splitting the data, that is test and train of splitting. Then hyperparameter tuning, such as best hyperparameter tuning is for best combination of the before parameters which we have gained from the decision trees. And then we have the metrics, that is like confusion metrics and classification report, which gives the precision, recall, and F1 score values and with the accuracy. Then we get the confusion matrix display. So we are using these parameters according to the age, height, weight, gender of a person, and the systolic blood pressure, which is taken off in int, and diastolic blood pressure and cholesterol, glucose, is the person is smoking or not, and the alcohol intake of a person, it is taken as binary, and physical activity, whether he is active or inactive. And the with these parameters we are finding the cardio of the person. So it is the classification or table which you can see in the code with 12 parameters. Then we are going to the first process, that is data pre-processing and exploratory analysis. So here we can see the analysis of the problem, that number of entries in the data frame and what are the missing values, and the what is the cardio duplicated values, and we can find the duplicated rows in the data set which are contained, and the output, the number of entries in the data frame are like 91,000, and the missing values are like 0, which we can see in the code. And then it is describing the cardio percentage, like what is the mean, standard deviation, and the minimum, as we have discussed earlier, the min max values and the recall values, accuracy and precision values. So for that we are finding the percentage, that is 25%, 50, 75, and the maximum values. Then we are going to the observation according to the age of a person, weight of a person, and his blood pressure. Then the next step, we are finding the outliers detection, that is according to the blood pressure, as you can see in the picture which have been displayed. Is it normal or elevated, or is he having the high blood pressure or the hyper extensive crisis, like below 120, or it is from 120 to 129, or it is from 130 to 139, it is high blood pressure. So we can have the theoretical values. According to that, we are estimating the outliers. Then after estimating the outliers, as we get like 1,275 outliers, and the percentage of missing rate is 1.8 percentage. Then after all classification of the outliers, the below is the graph which we have got to the data which we have taken, that is the cardio data of classifying all and removing the noise in the data, and clearing all the outliers and the errors. The next, we are we are checking IQR based filtering according to the height and weight. That is, it also depends upon the BMI of a person. Like according to the weight of your body, and what is the height of your body, your blood level, sugar level, and everything is to be maintained. That is the graph where we are comparing. Yes, that is about the outliers. Then down. Then BMI, as I said, that body mass index. Body mass index is the main criteria. Like every person in any medical or healthcare field, every person measures according to this index. And the flowchart what we have gained is the psychological fact that according to the percentage of your weight, you need to be to some of the height. So that is the chart diagram which we all need to follow to have a well balanced health in our daily ecosystem of this life. So this is the chart which we have gained according to the BMI. Next is the BMI classification of data, weight and height according to that analysis. Then according to the proportion of cardiovascular disease by gender, like how much to the male percent and the female percent, it is compared with a number of people in gender. Then the second stage is the feature engineering. Here is the system like where we are comparing with the different correlations, and estimating the noise values and removing the missed values with different parameters, as I have mentioned, like age, gender, height, weight, glucose level, cholesterol, is he active or inactive. Then coming to the ML models, in this project we are involving basically 6 ML models, as Yeswanth have mentioned in his earlier presenting the PPT. So once again, I'm recalling that logistic regression, then linear discriminant analysis, then the decision tree, gradient boost classification, k nearest neighbor algorithm, random forest, and the last one SVM, support vector mission. This is the basic model for scaling the data. Then I got into a tabular matrix, age, gender, height. That is the binary classification. Then we'll go into the logistic regression. Yes. Here, initializing the logistic regression model, uh, then we have been using the common binary classification problem, and then training the model using the training data x underscore train feature and y underscore train is the label. Then predicting the testing of the data. Then we have the accuracy score, that is log regression underscore accuracy, where we have that then the truth tables of the tested data, and we get the confusion matrix according to that, that is true positive, true negative, false positive, false negative, beyond the performance, and the sensitivity, that is also called as true positive rate. 1 minute, just drag down. Yeah, after having the confusion matrix, like we can see the values of precision, that is 0.71, and recall is 0.78, F1 score is 0.75, and then it is support value of 8,000 something. So overall accuracy is what we have gained is 0.73. It is of 73%, and TPR value is of 0.6%. Then we are going into the next model, that is linear discriminant analysis. It is generally mentioned as LSQR in the code. So we are using this for dimensionality reduction and classification by finding a linear combination of features that are like best separate classes, which we can resolve the outliers. Then this model can store the covariance matrix for the analysis. Then we are training this model as X train and Y train. Then predicting the test labels of them. Then classifying their probability, that predicting the value is greater than zero point 0.5, which results in 1, that is a positive class, and predicting the value less than or equal to zero point 0.5, which results in 0, that is negative class. Then finding the evaluation matrix, that is confusion matrix, which we have got the values like zero point 0.1 and 0.75, which is almost very nearer to the model of logistic regression. Then next we are going into the decision tree. As we know that machine learning model that is a decision tree that splits the data based on the features such as threshold. It has a classification like root nodes and leaf nodes and internal nodes and external nodes. As we know that it classifies into minimum sample and it splits then minimum number of sample required to split a node, it is like 2, and then we are training the data, then predicting as the same procedure, predicting the test labels and testing the data, then evaluation matrix. Here we are finding the accuracy as correct number of correct predictions by total number of predictions. So according to this score, we have got the confusion matrix, that is true positive, which is correct positive prediction in the tree, and true negative, false positive, false negative. The accuracy which we gained was 0.63 and the TPR rate was 0.62, which is a slight variation with the linear discriminant analysis. So the next comes gradient boost. So this is the okay. This is the decision tree diagram which we have derived from the above code. Like it is the root node where it is taking the age and some sample values. Then it is having a leaf nodes like cholesterol. Then the internal nodes as a glucose. Then so on the decision tree flowchart is there. Then according to the values, we have gained the tuned decision tree. Then with this tuned decision tree, we are having a trained version of the model. So the trained version of the model is evaluated with the validation accuracy, which we have gained in the previous iteration of the decision tree. So according to that max depth, we have been calculated. So the below graph is about the accuracy and the max depth. So you can see the variation before and the after tuned graph. So the accuracy may be increased in the tuned graph as we compare to the normal decision tree. Then the maximum leaf nodes have been adequated, and it shows a linear graph here. So this is the accuracy and the sensitivity and the precision value and F1 score, which you can see in confusion matrix. Then this is the decision tree of the tuned one, but the improvised version of the original tree, which we have gained in the previous iteration. Then next is the gradient boost classifier. So this comes with the multiple things. It is like a sequential improvising model. Uh, the gradient boost is automatically of complex individual trees, which can say like it prevents the overfitting and the underfitting problem. uh, Suppose if the number of boosting stages can be increased, but accuracy and what is about the risk. So this risk is called as overfitting. And when the maximum depth of each decision tree is more, then the complexity of individual tree is more. To prevent this, we are having the overfitting problem. So this can be solved by using the gradient boost by taking the minimum number of samples already which we have taken out this split and in the decision tree. So those can be used in the gradient boost. Then the model is trained with this, and then we get the evaluation metrics and confusion metrics. Then the next is random forest. Yes, in random forest we have the viewer mode, and if viewer mode is true, we have certain kind of flexible outcomes, and if the model is not having the viewer mode, then we have the certain kind of outputs. That is like prediction of the data and calculating the metrics. But here TPR rate is differ. Like what we are following the formula is like true positive values by true positive plus false negative. So in this, we have a different value. So displaying the matrix and displaying the confusion matrix, we got that chart. Then next, we have the precision rate and accuracy as zero 0.5 and sensitivity as 1. Then we are going into the random forest diagram, which we have got from the above algorithm. Then we are taking the support vector classifier. As we all know that this is the most complex model, but which is followed by everyone, like for any regression or classification. So SPM supports the best performance and accuracy in the same with taking the same data interpretation. So in the chart, you can see the accuracy and type and sensitivity, which we have compared with different models such as logistic, linear, and decision with different colors. So we can compare the flowchart and we can have a conclusion like SPM has a very good accuracy rate. It is very similar with a logistic and linear discriminant, though it is similar, but we can use as most used machine learning models as SVM support vector machine. So this is the project which we have gone through, and thank you. Do you know how to end this recording?